So second part of 4.2, we have transforms of derivatives. So first derivative, s times the capital F of s, meaning you need to take the inverse Laplace transform, but you will get the equation as y prime, y double prime. You just need to make a capital Y. There is a major difference between the capital and lowercase, so you have to be careful with that. And again, you don't have to remember any of this is on the equation sheets, and then you can just take a look at them. Okay. And then double prime, start with the s square f of s minus these. So lowercase f, meaning the initial conditions. So you will be given initial conditions for f prime or f double prime and f triple prime. And you have to use those initial conditions too here. Okay. Once we have an example, you'll see everything is going to be clear. So going from here to here, you just need to apply Laplace transform. But from here to here, when you apply inverse Laplace transform, you need to take the partial fractions. So you need to know the partial fractions. Let's do this. So you're given dy over dt plus 3y equals 13 sine 2t. So this is y prime of t plus 3y equals 13 sine 2t. So let's take the Laplace transform. Y prime t. S capital Y of S minus Y of 0. That's the Laplace transform of this prime. Plus 3 capital Y of S equals, so we have 13 times sine 2t, denominator s squared plus 2 squared for both sine and cosine. Cosine for the numerator is s, sine is just this k. Then s capital ys minus y sub 0 is a 6 plus 3 y of s equals 26 over s squared plus 4. I'm going to factor out y of s. So we have s plus 3 capital Y of s equals, the rest we're going to move to the right hand side. 26 over s squared plus 4 plus 6. That equals s squared plus 4. And we need to make the common denominator. And first term we'll have 26. The second term, 6 times s squared plus 4. So that way, when we separate this, we end up getting the same one. Then we have s plus 3 capital Y of s equals 6s squared plus 24 plus 26 over s squared plus 4. Now, we can divide both sides by s plus 3. Then we have y of s equals 6s squared plus 50 for numerator, and then denominator s squared plus 4, s plus 3. Now we need to use partial fraction to separate the denominator. For the first one, s squared plus 4, the denominator is a square term, so numerator has to be as plus b, s squared plus 4, plus the second term is s plus 3. So for the numerator, only 1. Now, when we make the common denominator, numerator, it's going to be as squared plus 3as. Now for b, bs plus 3b. C terms, cs squared plus 4c. Now we're going to compare this numerator with this numerator, square term, square term. So a plus c equals to 6, and then constant term 3b plus 4c equals 50, and we have s terms 3a plus b equals to 0 because we don't have S term. From the last one, we have B equals negative 3A, and plug it in here. Negative 9A plus 4C equals to 50. 4A plus 4C equals 24. And we subtract minus 9 minus 4. So negative 13A equals 26. So then A equals negative 2. Use this equation. Negative 2 plus C equals to 6. C equals to 8. And you can substitute here. B equals positive 6. So the equation now, y of s equals a negative 2s plus 6 over s squared plus 4 plus c 8 over s plus 3. Now we're ready to take inverse Laplace transform of this. So for the second term is easy, but for the first term, we have to separate them. I mean, if we have square term at the denominator and we put s plus 1 for the shifting property, first translation property, if that is the case, we don't want to separate them. But other than that, we need, when you see s plus something in the numerator, you need to separate them. We have negative 2s over s squared plus 4 plus 6 over s squared plus 4 plus 8 over s plus 3. So we have s up there. And rewrite negative 2 times s over s squared plus 2 squared. And then I'm going to write down 6 in front. And then we have s squared plus 2 squared. So we have to have a 2 for cosine. Since we put 2 there, we need to multiply 1 over 2 plus 8 over s plus 3. Now we can take the inverse Laplace transform. So lowercase y of t equals negative 2 cosine 2t plus 6 over 2, which is 3 sine 2t plus 8 times e to the negative 3t. Let's try to solve this differential equation without using Laplace transform. So X equation, we have m plus 3 equals to 0. That is m equals to negative 3. So yc equals c1 e to the, and then yp, by looking at the right hand side, 13 sine 2t. So I have to let yp as a cosine 2t plus b sine 2. Now we need to take the prime of this, 2a, negative 2a sine 2 plus cosine 2t. And left-hand side, yp prime plus 3yp, this plus 3 times a t plus 3t. Sine 2t terms and cosine 2t terms. Sine 2t, so negative 2a plus 3b, cosine 2t, 2b plus 3a. 13 sine 2t, 2t should be 13, cosine 2t should be 0. Multiply 6a 0, add 13b to 3, 2 times 3a negative 6, therefore equals a b plus 3 sine 2, y equals c1 e to t. Initial condition y0 equals to 6 as an initial condition. You plug it in. 6 equals c1 minus 2 cosine 0 plus 3 sine 0. This is 0. This is 1. C1 equals 8. So our answer is 8e to the negative 3t minus 2 cosine 2t plus 3 sine 2t, which is what we have here. 2 times dy over dt plus y. So like the Laplace transform, we have a 2 times y prime is going to be s times y of s minus y of 0 plus y is just y of s equals 0. And initial condition was y of 0 equals to negative 3. Plug it in. Now we have 2s capital Y of s minus 2 times negative 3 plus y of s equals to 0. And we have 2s plus 1 for capital Y of s. And then negative 2 times negative 3 is a positive 6. You move it to the other side, it's going to be negative 6. And capital Y of s equals negative 6 over 2s plus 1. We can divide top and bottom by 2, negative 3, 1 over s plus 1 over 2. And if you take the inverse Laplace transform, that is negative 3 e to the negative 1 over 2t. Let's quick review chapter 2. This is first order differential equation. This is not standard form, so we're going to divide everywhere by 2, y prime plus 1 over 2y equals to 0. It's a linear integrating factor, e to the integral 1 over 2, that is e to the 1 over 2t. You multiply this integrating factor to everywhere, we have dy over dt e to the 1 half t plus 1 over 2 y times e to the 1 over 2 t equals 0. Left hand side, it's going to be d over dt y e to the 1 over 2 t equals 0. Take the integral, then we have y times e to the 1 over 2 t equals to c. Y equals c e to the negative 1 over 2t. Initial condition y 0 equals to negative 3. So negative 3 equals c e to the 0. So c is negative 3. So we end up getting the same answer. Let's do this. Now it is a double prime. Y double prime is going to be s squared y of s minus s y of 0 minus y prime of 0 plus 5 times y prime s y of s minus y of 0 plus 4 y of s equals to 0. Y of 0 equals to 1. So this is 1. This is 1. And y prime of 0 is 0. Then we have s squared y of s minus s plus 5s capital Y of s. 5 times negative 1, negative 5 plus 4 y of s equals to 0. Please note on that y double prime has only one capital Y of s, and y prime also only one capital Y of s. I have seen many students just multiplying this s times y of s, but it's not. Collect capital Y of s, s squared plus 5s plus 4. That's all for capital Y of s. And the rest move to the other side. That is s plus 5. And then capital Y of s equals now, we have s plus 5 over s squared plus 5s plus 4. Denominator is s plus 1, s plus 4. Numerator, s plus 5. But now we need to do the partial fraction to separate the denominator. And we're going to let that equal to a over s plus 1 plus b over s plus 4. And combining these together, s plus 1, s plus 4, numerator is going to be as plus 4a plus bs plus b. And we are comparing this numerator with this. So s terms a plus b has to be 1, and constant term 4a plus b equals to 5. Subtract to get rid of b. Negative 3a equals negative 4. A is 4 over 3, and then means b has to be negative 1 over 3, so that when we add them, it's going to be 1. Now we have capital Y of S equals a 4 over 3 times 1 over S plus 1 plus negative 1 over 3 times 1 over S plus 4. Now we are ready to take the inverse Laplace transform of this. Y of t equals 4 over 3 e to the negative t minus 1 over 3 e to the negative 4t. In chapter 3, we can just find the Ox equation from here. M squared plus 5m plus 4 equals to 0. And we end up getting m equals negative 1 and m equals to negative 4. So the solution is C1 e to the negative t plus C2 e to the negative 4t. Now using those initial conditions, we can find the C1 and C2. We can get the same answer. Let's work on this. Y double prime S squared Y of S minus sy of 0 minus y prime of 0 minus 3 y prime sy of s minus y of 0 plus 2y of s equals the Laplace transform of e to the negative 4t. It is 1 over s plus 4. We have y0 as a 1. So this is 1. This is 1. Y prime of 0 is 5. This is 5. Squared y of s minus s minus 5 minus 3s y of s minus 3 times negative 1 plus 3 plus 2 y of s equals 1 over s plus 4. So let's factor up y of s. S squared minus 3s plus 2 y of s, and move everything else to the right-hand side. 1 over s plus 4 plus s plus 5 minus 3. Before we divide everything by s squared minus 3s plus 2, we need to take care of the right-hand side. Put them into 1. 1 over s plus 4 plus s plus 2. Therefore, if we have a common denominator, we have to have a s plus 4. The first term is 1 plus, when we have s plus 2, for the numerator, same denominator, we need to multiply s plus 4 there, and that equals s squared plus 2s plus 4s, which is 6s. 2 times 4, 8, plus 1, which is 9. And denominator s plus 4. Now we are ready to divide both sides by s squared minus 3s plus 2. When we do, we have y of s equals denominator s plus 4 and s squared plus 3s plus 2 is s minus 1, s minus 2. For the numerator, we have s squared plus 6s plus 9. Now we need to do the partial fraction. A over, I'm going to use s minus 1, s minus 2 first. S minus 1 plus b, s minus 2 plus c, s plus 4. Let's have the common denominator. S minus 1, s minus 2, s plus 4. For 8 terms, I have the s minus 1 at the denominator, so I do need s minus 2 and s plus 4. For BD, I have s minus 2 at the denominator, so I need s minus 1 and s plus 4. For C, I have s plus 4 at my denominator, therefore I need s minus 1 and s minus 2. Now I'm going to write numerator, this equals to this. We have s squared plus 6s plus 9 equals as minus 2 s plus 4 plus b s minus 1 s plus 4 plus c s minus 1 s minus 2. So far, when we work on this partial fraction, we expand every single term and collect the square term from right-hand side and compare with the left-hand side, which is 1. And then we expand everything on the right-hand side and collect all those s terms, compare with the left-hand side and 6. We can do that. However, when we have something like this, easier way, if I let s equals to 2, then left-hand side, I have 2 squared plus 6 times 2 plus 9. This equals to b times s is what? At 2. So 2 minus 1 and 2 plus 4. And this is 4 plus 12 plus 9, 6 equals 6 times b. So we have b equals 25 over 6. So a little bit easier. Now, similar way, we let s equals to -4. Then this guy is going to go away. Then we have -4 squared plus 6 times -4 plus 9 equals c -4 minus 1, -4 minus 2. So now we have 16 minus 24 plus 9 equals c -5, -6. This is 25 minus 24, so it's 1. And then 30 c. So from here, c equals 1 over 30. Now we let s equals to 1. Then this is 0. This is 0. So we have 1 plus 6 plus 9 equals a. 1 minus 2, 1 plus 4, 16 equals -5a. So from here, a equals -16 over 5. So now we put it back. Y of s -16 over 5, 1 over s minus 1, plus b 25 over 6, 1 over s minus 2, c plus 1 over 30, and 1 over s plus 4. Now we are ready to take the inverse Laplace transform of this. Y of t equals -16 over 5 e to the positive t plus 25 over 6 e to the 2t plus 1 over 30 e to the -4t.